Video is a continuation from the last, where we use the definition of the derivative to find the slope of the tangent line of this function at the specific x value of 2. We're now going to continue that video and do the same thing. We're going to find the slope of the tangent line, also called the derivative of a function, of the same function, this time at a non-specific x value, a. So this is when x equals a constant a. So I'm going to take a look at that. That's how it's going to look. So we're just like the last example, and I would recommend, if you haven't seen that one yet, to look at that demonstration, because this one is just a little bit of a step up from that. Not much, though. So our slope is going to be, let's see, we're going to plug wherever there was an x, now we're plugging in a plus h. So that's going to say 3 times a plus h, the quantity squared, plus 7. That's f of a plus h, minus, here's f of a, which would be 3a squared plus 7, all over h. Okay, as we continue to simplify, we're going to square that binomial, which will be a squared plus 2ah plus h squared. Then we have this plus 7. And we're going to distribute this negative sign and see that it's negative 3a squared minus 7 all over h. Continuing, let's kind of skip a step here. We're going to distribute the well, maybe we won't. Let's just distribute the 3 here to avoid. We're not going to skip a step here just so we avoid confusion. All right. So let's see what happens. And this, again, I think I've mentioned it in the last video, but if you've done this correctly, some nice things are going to cancel here. Notice that 3a squared and negative 3a squared cancel. Notice that the 7 and negative 7 cancel. We can now factor an h out of the numerator, and we'll have 6a plus 3h, and that's it, all over h. The h's then cancel, and we can then evaluate our limit as h approaches 0. So this term approaches 0, and we're left with 6a. So what this means is, if we want to find the slope of this function at any x value, in this case it was a, all we have to do is take 6 times that a value, 6 times that x value. And if you recall from the last video, our answer was 12, and if we use this formula and say, alright, well, how about at the specific value x equals 2? If we plug 2 in for a, that tells us at the x value of 2, our slope of the function would be 12. So we can say the slope of our function is 6a. Later on, we'll identify that the derivative of our function is 6x. But that's coming a little bit later here. The derivative, this is called f prime of x, is equal to 6x. The derivative of our function f is equal to 6 times x.